So, what if I told you that in just 7 days, you could build a really solid foundation in data structures and algorithms, DSA, that would let you solve more than half of all the easy interview problems out there? Well, in this explainer, we're going to dive into a super simple but powerful plan to get you started.
Look, if you're just starting out, the world of data structures and algorithms can feel huge, maybe even a little overwhelming. Like, where do you even begin? That is a totally common feeling. But honestly, a focused start makes all the difference.
And that's exactly what this is all about. We're going to focus on 4 absolutely essential patterns that give you the biggest bang for your buck time-wise. This isn't about learning everything all at once. It's about learning the right things first.
Okay, before we get to the patterns themselves, we need a way to talk about them, right? How do we measure if one solution is actually better than another? That's where we've got to start, with the language of code efficiency.
Now, this might sound a little academic, but the idea is actually pretty simple. We just want to understand how our code's performance changes as we give it more and more data. The fancy term for this is asymptotic complexity, and we usually measure it with something called Big O notation. Think of it as the language we use to talk about efficiency.
For your first week, you really only need to get these 3 in your head. O of 1, or constant time, means it doesn't matter how big the input is, the work is always the same. Then you have O of n, or linear time, which means if you double the input, you basically double the work. But the real magic one is O of log n, logarithmic time, where doubling the input barely even increases the work at all.
And this chart just shows the difference perfectly. For a million items, a linear algorithm is going to take a million steps. A logarithmic one, it takes about 20. 20! That's not just a little better. It's a completely different universe of efficiency. Getting this concept is your first superpower.
So, with our new language of efficiency, let's start building our core toolkit. These are the 4 patterns that you're going to see come up over and over and over again on your problem-solving journey.
First up is binary search. This is our star example of that incredibly efficient O log n complexity we were just talking about. It's a technique for finding things really, really fast.
Now, the most important thing here, the one non-negotiable rule, is that the data has to be sorted. If it is, you can find a specific value at incredible speed. But even cooler, you can use it to find the exact point where some condition changes from false to true. Like pinpointing the very first bad version of a software release. That's the kind of problem binary search just eats for breakfast.
And the process itself is it's so elegant. You've got your sorted list, you point to the start and you point to the end. You check the element right in the middle. Is your target higher or lower? And depending on that answer, you just throw away half the list. You do it again and again, having your search space with every single step. It's simple and it is lightning fast.
All right, next up is our second pattern, the hash map. You might know it as a dictionary if you use Python. This is your go-to tool whenever you need to store and retrieve data with almost instant O of 1 lookups.
So when do you use a hash map? Simple. Anytime you need to quickly ask the question, have I seen this thing before? The order of the items doesn't matter, just whether they exist or not. The absolute classic example is the two-sum problem. Given a list of numbers, can you find 2 of them that add up to a target? A hash map makes this incredibly easy.
This analogy explains it perfectly. As you walk through your list of numbers, you're looking for a partner for each one. It's complement. So you check your ledger, that's the hash map, to see if the partner you need has already been seen. If it has, boom, you're done. If not, you just add the current number to the ledger, so it can be a partner for some number you see later. It's just one simple pass through the data.
Our third pattern is the sliding window. This technique is just brilliant for problems that deal with continuous chunks of data, like subarrays or substrings.
So, whenever a problem asks you for something like the maximum sum of a subarray of size k, your brain should immediately go sliding window. The whole point is to avoid doing the same work over and over again. You basically create a window of a certain size and just slide it across your data, one element at a time.
I absolutely love this visual. Instead of adding up all the buildings inside your window every single time you move it, you do something way smarter. When the window slides one step to the right, you just subtract the value of the building that just left the window, and you add the value of the building that just entered. It's a constant time update, which makes the whole algorithm super fast. O of n.
And finally, our fourth pattern is the stack. This is a pretty simple data structure with one very strict rule: last in, first out, or LIFO. Think of a stack of plates. The last plate you put on top is the first one you take off.
Stacks are perfect for any problem that involves matching or nesting things. You know, like the undo function in a text editor, or the back button in your browser. But the most famous interview problem for this is validating parentheses, making sure every open bracket has a matching closed bracket in the correct order. This nesting boxes analogy is really the key. When you see an opening parenthesis, like open, it's like you're putting an open box onto a stack. When you see a closing parenthesis, like close, you have to find a matching open box right on top of that stack to close it. If the box on top doesn't match, or if you have leftover open boxes at the end, well, then the whole structure is invalid.
Okay, so you've got the 4 patterns. Now, how do you actually use this knowledge to stand out in a technical interview? It all comes down to understanding the trade-offs.
This right here is one of the most important conversations you can have in an interview, the trade-off between time and space. Let's go back to that to-sum problem. You can solve it in really fast ON time using a hash map, but that uses extra memory. Or you could sort the array first, which takes a bit longer, ON log n time, and then solve it using no extra memory at all. Neither one is wrong. But being able to talk about this choice and maybe even ask the interviewer which is more important for this system shows that you're thinking like a real engineer, not just someone who memorized one solution.
So there it is, your action plan for week 1. First, get really comfortable with Big O. Then, just tackle each of these 4 patterns. For each one, make sure you understand when to use it and then try implementing it yourself. This focused practice is, hands down, the fastest way to build real confidence.
By mastering these fundamentals, you've built an absolutely incredible foundation. You're ready to move on from these simple, linear structures to more complex ones. The question isn't, where do I even start anymore? Now it's, what's next? And that's where things get really fun, with topics like trees, recursion, and all the exciting challenges that are waiting for you in week 2.